Dear students, welcome to you all in another mathematics class. Today we are going to discuss about parallel straight lines. This is the third class on this topic, which is discussed in chapter 8 of your mathematics book. I am Shudipan Bhattacharya. I am with you on this discussion. So, the topics of this class are uh, proof of two theorem, which are if two parallel straight lines are intersected by another straight line, then the alternate angles are equal. And another theorem is if two parallel straight lines are intersected by another straight line, then sum of the internal angles of the same side of the transversal is equal to two right angles. That is, sum of the internal angles of the same side of the transversal is equal to two right angles. First note, as the definition of parallel straight lines, we know that the two straight lines are parallel if and only if the corresponding angles produced by a transversal are equal, the alternate angles produced by a transversal are equal, and the sum of internal angles uh, of the same side of a transversal is two right angles. We can take any of these three as the definition of parallelism and prove the other two. In today's discussion, we will take that the corresponding angles are equal as the definition of parallelism and prove the other two. So, first theorem. If two parallel straight lines are intersected by another straight line, then the alternate angles are equal. So, from the last class, we have learned that if AB and CD are two parallel straight lines and PQ is the transversal, that is another straight line which is intersecting AB and CD at the point E and AF, then we know that alternate angles are these angles AEF and DFE. These two angles are alternate, and also CFE and BEF are also alternate angles. And corresponding angles are DFP or DFE and BEP. They are corresponding angles. This angle and this angle are corresponding. This angle and this angle are alternate angles. So, for particular enunciation, we can write that let AB and CD are two parallel straight lines. PQ is another straight line which intersect AB and CD at E and F respectively. We have to prove that angle AEF is equal to angle EFD. That is, angle AEF means this angle and angle EFD means this angle. We have to prove that these two angles are equal. Uh, as the definition of parallelism, we can take that the corresponding angles produced among AB and CD are equal. So, we can write that angle PEB is equal to angle EFD. So to do that, as the proof, we have written, as we said, as the definition of parallelism, we can take that the corresponding angles produced among AB and CD are equal, and angle PEB is equal to corresponding angle EFD. Now we can see that angle PEB is also equal to angle AEF. angle PEB is also equal to angle AEF. Why? Because they are vertically opposite angles among AB and PQ. So we can write again angle PEB is equal to vertically opposite angle AEF. So we can mark these two equations with 1 and 2, and then we can find that PEB is equal to EFD and PEB is also equal to AEF. So these three angles are equal. So you can write PEB is equal to EFD is equal to AEF. You can see that PEB is equal to EFD and also PEB is equal to AEF. So angle PEB is equal to angle EFD is equal to angle AEF. Now, if we eliminate PEB from here, that is, if we overlook PEB here, then we can get EFD equal to angle AEF. So we can write angle AEF is equal to EFD, which is alternate. So angle AEF is equal to alternate angle EFD. So our proof completes here. Now we are going to prove the another statement, which is if two parallel straight lines are intersected by another straight line, then sum of the interior angles of the same side of the transversal is two right angles. To see in figure, we can draw a straight line AB and another straight line CD, and we draw a transversal which is PQ, and then uh, name the points of intersection as E and F respectively. And we can write the particular enunciation like this. Let AB and CD are two parallel straight lines. AB and CD are two parallel straight lines. PQ is another straight line which intersect AB and CD at E and F respectively. We have to prove that angle BEF plus angle DFE equal to two right angles. So we are going to see which angles are there. You can see angle BEF. So we can see angle BEF here. This angle is called angle BEF. And also angle DFE, which is this angle. So the statement says that if you take sum of these two angles, then the resultant will be two right angles, that is 180 degree. So now we are going to watch what happens here in the proof, how to prove this statement. So as the definition of parallelism, we can take that the corresponding angles produced among AB and CD are equal. Corresponding angles produced among AB and CD are equal, which is PEB is equal to corresponding angle EFD. So we can write that corresponding angles PEB and EFD, they are equal, as we have written in the previous theorem. And we have marked this equation as equation 1. And then again angle BEF plus angle PEB is equal to two right angles. You can see that here, which is angle BEF, that is BEF, and PEB, which is PEB. These two angles will make two right angles. How? You can see angle BEF and PEB these two angles makes a straight angle. You can see here two right angles. Now BEP is also equal to DFE. So if we replace BEP by DFE, then what happens? If we replace PEB using the same value DFE or EFD, then also we will get two right angles, because here PEB and EFD, they are having same value. Suppose PEB is x. If PEB is x degree, then EFD is also x degree. So when you add them, PEB plus BEF is equal to, and that is, take it as y. If this is x plus y degree, then this is also x plus y degree. So if BEF plus PEB is equal to two right angles, then BEF plus EFD is also equal to two right angles. If x plus y here are two right angles, then this x plus y is also two right angles. This is the concept of this theorem. So we have what we have done here, we have replaced angle PEB by equal value angle EFD. So here comes the proof. Now you have some CW and HW for this class. As the CW, you have to write down the definition of parallelism of two straight lines and prove the theorems you have learned from this class by yourselves. And as HW, for the following figure, you have to prove that angle PAB equal to angle SBA. And also you have to prove that angle PAB plus angle RBA is equal to two right angles. So thank you for attending this class. I hope you will submit your CW and HW very soon to me, and you will keep going studying seriously, because we have to overcome the corona situation. Thank you.